Okay, YouTube, in this video, we're just going to look at another example of basically calculating joint and marginal relative frequencies as well as conditional relative frequencies. And so what we're going to look at here is just basically the data that we had used in our extra example number one concerning I guess a debate competition, which we had juniors and seniors competing, and some that qualified and some that did not qualify for like a state competition. So basically we have our joint frequencies here and our marginal frequencies, but what we want to do is convert these into joint relative frequencies and marginal relative frequencies by basically taking all of these values here and dividing them by the total number of elements in the data set in the first place. So what we're going to do is we're basically going to recreate this table here. So let's go ahead and extend our rows and our columns here. So we'll go ahead and throw these in here. Need 2 rows and 2 columns. You should always leave one for a total here. And so when we look at this, I'm going to just say this is a junior, this is a senior, this is qualified, and this is not qualified. And so we should get a total amount here, total here, in our margins, and then a total down in the bottom right. So basically what we're going to be doing is just grabbing our calculators and taking all of these values that existed in the table in the first place and dividing them by 40. So we have 7/40, 19 divided by 40, and then down here we get 26 divided by 40. Likewise, we're going to get 9 divided by 40 here. This would be 5 divided by 40 here, and then we'd get 14 divided by 40 here. And then on our furthest right margin here, our column, we have 16/40, 16 out of 40 chance of getting that. We'd say 24 out of 40 here. And then down here, interestingly enough, should be the total of this. We say all 40/40. So this one is going to be easy to determine here. In terms of all of these other values, of course, we just grab a calculator, and so we'd say, calculating a few of these, we have 7/40, 0.175. So we'll go ahead and fill this in here, 0.175. If we fill out 9/40 now, so we'd say 9 divided by 40, we get 0.225, so we say 0.225. The interesting thing is if we were to add those together, we should get what we get for 16/40, which 16 divided by 40 is 0.4, and these do indeed add up to 0.4. So I'm going to write 0.400. Now, with respect to what we have down here, I suppose we could say that this right here had better be 0.600 because it's got to add up with my 0.400 to be 1. Also, looking at these, we say 19 divided by 40. That's going to be a little bit less than a half. We say 19 divided by 40 here. We say 0.475, so 0.475. And we say 5/40, that's the same as 1/8. So we say 5/40. We get 0.125. Now, 0.125, we could have found that by taking this 0.6 over here and subtracting off the 0.475. But with what we got down here in these bottom two margins, let's go ahead and find these by just adding up our joint relative frequencies to get our marginal relative frequencies here. So we would say the 0.175 up top left here plus the 0.475 here would give us 0.65. And as a matter of fact, I'm going to say because that's 65% right there, this has got to be the other 35% that did not qualify. And so looking at these, now we have our joint relative frequencies as well as our marginal relative frequencies. And so as we interpret these, we can look at all of the joint relative frequencies, like this 0.175 is representing the probability that a junior qualified for state in this bunch of people. Or this 0.225 is a junior that did not qualify for state. And if we were to look at our marginal now relative frequencies, we could look at this frequency or this probability here as basically being the likelihood that a junior was in this group of kids here, or basically 40% of them were juniors and 60% were seniors. Likewise, down here, when we look at these marginal relative frequencies, we're looking at basically the percentage of overall qualifiers and the percentage of overall non-qualifiers. So looking at this table here, what we're going to do is we're going to use this table to now construct a conditional relative frequency. So we say that using the debate competition here, we want to make a two-way table that shows the conditional relative frequencies based on the total in the rows, okay? So when we make this new table, the interesting thing here is we're still going to recreate it here, and you want to leave yourself some room. So we would have room to fill in some of these values here. So we have qualified and not qualified. Also, we have junior and senior, and of course we have totals along the outside. Essentially, what we're going to be doing now is to find the conditional relative probabilities. We're going to take each of these individual joint probabilities and divide them by the overall probability for that row, or the marginal relative probability there. So basically, what we're looking at is, of all of the juniors here, what percentage of the juniors qualified for state? And so what we're going to do is we're going to take this 0.175 that was our joint relative probability and divide it by the marginal relative probability. And we said for that row, we were interested in the row totals and not the column totals down here, this 0.65. So really we're going to grab everything in this row and we're going to divide it by the marginal relative probability there. And we're going to get some new values. As a matter of fact, let's go ahead and fill out this row down here. We would say 0.475 was its value, 0.475. And this would be over its row marginal relative probability here. We say 0.600, just 2 zeros. And then looking over here, this is also out of the row total here, 0.600. We have 0.125 as its joint probability. So again, dividing the joint probabilities by either their column probabilities or the marginal column probability or the marginal relative row probability, you're going to get these values here. And so what I'd like to do is just kind of get our calculators out here. We say if I were to take this 0.175, so we say 0.175 and divide it by 0.400, we'd end up with about 4375. And so you know what, I'll switch colors on us here. I didn't leave myself a lot of room, but we would say that this is 0.4375 is going to be its conditional probability. Now when we take 0.225 divided by 0.400, we're saying of all of the juniors, how many did not qualify? And we could say 56.25%, so 0.5625. Essentially, 56.25% of the juniors did not qualify, and then 43.75% of the juniors actually did qualify. And those should add up to be 100% of the total juniors. Now looking at the seniors, we say what percentage of the seniors qualified. You can see that a greater percentage of the seniors qualified here. If we take 0.475 divided by 0.600, then we'd say that 0.7917 roughly, we'd say 0.7917. So it was very likely that you qualified if you were a senior, 79.17% of the time. And you can see that this is, as we take it away from 1, if we were to take this probability away from 1, minus 1, check out this number, 0.20833. Let's do this. We'll take 0.125 divided by 0.6, and there's this number again. So 0.2083 is the likelihood here, and not just any likelihood, but the conditional relative frequency or conditional relative likelihood of the rows. Cheers.